Welcome to episode 9 of our series Back to Basics Business Technology Platform. Episode 9 is explaining how all the solutions we've talked about in the previous episodes from 1 to 8 can be put together in order to bring the best results for the company. Now, this exercise is very complex because the solutions can be seen in different ways. Therefore, episode 9 is basically composed in 3 episodes. So we have decided to give you 3 episodes, 9A, 9B and 9C, because the solutions put together can be seen from an technology perspective, can be seen from an application perspective, and of course can be seen from a solution deployment type of architecture. Welcome to episode 9A. In our journey into the data world, we mentioned multiple technologies and numerous domains of applications. One by one, we enumerated categories of products and various topics requiring attention of any data management decision maker. It is now time to assemble them all and try to see how they can integrate efficiently. Obviously, it is not possible to provide a single and simple architecture to articulate all the data inside a complex organization. In the late 80s, the concept of a universal database capable of managing any data for any purpose rapidly showed its limits because, on one side, the progress of hardware compensated the data management weaknesses of the software, but on the other side, adapting software to the new requirement revealed itself very challenging to achieve. Therefore, it appeared very often that adopting a new technology was more efficient than adapting an old one. Meanwhile, you cannot easily get rid of all technologies, favoring therefore the emergence of siloed architecture. Every line of business, every department, every type of activity has its own requirements when it comes to data. We must understand the different profiles, the roles producing or consuming data. What are the requirements, constraints, objectives? The already mentioned how, when, what, where, how, and why questions. In an industrial process, data might be produced at a very high rate by different monitoring systems. On one side, they require immediate attention if something suspect occurs. But on the other side, the same data may be used in a delayed in-depth analysis to validate the factory process runs accordingly to the objectives. Another example could be financial processes where a dealing room reacts immediately to stock variation, but processes and validates the buying and sales of actions at a slower pace. The same data are used by various applications serving different goals with different processing requirements. Let's take an example. Suppose we have a sensor monitoring the temperature of an engine, like you probably have in your own car. The sensor sends every second a data value it collected from a probe, but we see that erratically it fails to do so. Using a time series engine, we can fill the missing values by a calculated one to reproduce the behavior of the engine temperature. In a second step, we can actually replace all the existing values by ones and all the missing ones by zeros. Consequently, what we observe is the behavior of the sensor, not the engine, and we can possibly start maintenance operations to replace this defect component. As you can see, data quality is relative to what we want to observe. Poor quality to observe the engine, but good quality to observe the sensor. Same remark can come when speaking about the truth. Until recently, the ultimate goal of any information system was to provide a single version of the truth, something that is the undisputed version of a certain reality. With the rise of new technologies like artificial intelligence, it is possible to get from the data as many interpretations as the human brain can provide. This picture seems to represent a parrot. But if we look closer, we can see some strange detail that makes us realize it's not only a parrot. Zooming into the picture, we realize that we have a human model whose makeup makes she looks like a parrot. Where is the truth? Do we see a bird or do we see a human being? In that case, both are true. Today, it is often said technologies are categorized in three areas. The first one relates to information, or IT, information technology, meaning the application of computers to store, study, retrieve, transmit, and manipulate data or information, often in the context of business or other enterprise processes. Secondly, we have the operational technologies, or OT, which is a category of hardware and software that monitors and controls how physical devices perform, typically sensors, probes, monitoring tools. And finally, the knowledge technologies, or KT, which is a category of software systems that can represent, interpret, formalize, or interrogate phenomena and create models of how the world works. All along this series of videos, we mentioned various terms related to data management. We will attempt now to position them in this helicopter view of data architecture. A little warning first, this is purely theoretical. Practical cases show we can adapt concepts and products to correspond to a reality that might be very different. A requirement might be covered by different concepts or products that, in their turn, can cover different requirements. Collecting information to position adequately a concept or a product is essential. In episode 1, we mentioned data technologies like relational or NoSQL databases. These databases can be considered as all-purpose databases, in the sense they can be used almost everywhere, but will probably coexist in different contexts. Relational database management systems, RDBMS, are definitely the primary choice for OLTP applications, online transactional processes, while NoSQL is more adapted to data produced in unstructured document format and designed for analytical processes, rarely for OLTPs. RDBMS can handle a large number of concurrent users, while NoSQL is designed to handle very flexible data structures and possibly very high volume. Until 2010, the trend was to minimize the utilization of file systems to store the data. The rise of big data revitalized them, as many organizations wanted to keep every data produced, even if not knowing yet what to do with it. For cost reduction purposes, file systems were considered primary candidate to store this impressive amounts of data, knowing hyperscalers are today proposing infrastructures to handle this at reasonable costs. As it is not possible to store all data into a single database, we are often forced to access them remotely, possibly duplicate them or move them from one location to another. Technologies like replication, ETL, extraction, transformation, load, or remote data access were developed mostly to bypass the weaknesses of data technologies used to observe and serve OLTP applications. Even if they are still largely used in the IT area, they do not really fit in the context of OT or KT. For a long time, stream data were managed outside the traditional IT area, as it was very difficult to combine streams and transactional data. With the hardware and software enhancements, it is now possible to force interaction between data streamed from OT and the data residing in OLTP databases. Also, very often, streamed data are stored and considered as valuable source of information for KT. The main benefit of having a database platform is it can be used for any purpose and any type of data, becoming a relevant set of integrated technologies covering IT, OT, as well as KT. A database platform is called multimodal when it has the ability to embed multiple data engines and can interact seamlessly with various integration engines. When various database sources need to interact together, many quality checks have to be performed, not only to validate the values inside the single data source, but also in regards of other data residing in other data sources. This is particularly true in the context of IT area, as it may impact the way an application behaves, while in the context of OT and KT, these validations can commonly weight the actual usage of the data to be validated. Unless the data engine is designed for coexistence of the OLTP and analytical schemas like SAP HANA allows, many IT organizations decided to create additional repositories to differentiate the schemas for transactional environment and the schemas for data warehousing. With the advances in database technology, some OT and or KT can be included in the warehouse, but this is usually representing a small portion of the data warehouse. As the data warehouse can only manage a limited number of data sources and data types, and also serves very well predefined analysis, the concept of data lake emerged in the last decade to allow the integration of all the data an enterprise may need. Purpose is to analyze the past, observe the present, and predict the future. Data lake does not only deal with the IT, OT, and KT data produced internally, but can also consider external to the organization data sources, like the ones provided by web services. To allow a user to trust the information he gets from a system, it is very important to describe what it is, how to interpret the values, where do they come from, when were they calculated, and so on. Very big efforts have been made to create descriptions of the data models, or metadata, in the context of IT application, but these efforts were focusing mostly on the IT landscape, OT and KT being de facto considered as silos and not integrated with IT data structures. When the concept of big data rose, it became obvious that all the data from all the areas had to be described, as the need to exploit IT, OT, and KT data together surfaced. The concept of data catalog, therefore, was born, allowing centralized description of all data used by all users. Describing everything about all the data any user can access, it rapidly became obvious that having everything into one single repository as a kind of super data warehouse was unrealistic. So instead of acting over all the data at the level of the data engine, people started to imagine an integration platform reaching the data where they are located and integrated them dynamically in regards to the analysis to be performed. This data orchestration therefore allows the integration of all the data storage technologies, but also of all the data processing technologies. Now that we know a little bit more about the technologies, how they work together with these solutions, I see you next time in the next episode, which will be 9b, in which we will see them with a focus of applications. See you soon. Thank you very much for attending all this series of videos. Hope they were useful, and we see you next time for the next series of other videos. Bye bye!